Okay, let's dive right into this. For a really long time now, we've kind of viewed AI and software development as just a super fast syntax checker, right? Like a souped-up linter that might occasionally autocomplete a line of code for you. But what the data is showing us today is an entirely different reality. We are looking at a fundamental shift, where AI isn't just fixing typos anymore. It's actually acting as a massive amplifier of team quality. So, in today's explainer, we're unpacking semantic intelligence and multi-role agents and exploring how they are literally redefining what it means to review code.
Here's a quick look at our agenda. We're going to cover the pull request bottleneck, move beyond syntax, break down the multi-agent workflow, see how we're catching design flaws, dive into some real-world metrics, and finally, map out the 2026 tool ecosystem.
All right, Section 1, the pull request bottleneck. Let's set the stage here.
If you're working in any modern development pipeline, you already know that writing the actual code is rarely the holdup. It's the pull requests. The data shows that manual review turnaround can take upwards of 4 days in mid to large organizations. Just think about what that does to your momentum. You write a feature, you submit it, and you wait. You end up context switching to another ticket, only to get dragged back days later to fix some minor formatting issue. It's basically mental whiplash, and it's a massive drag on overall productivity.
In fact, these human bottlenecks stall feature releases by up to 30%. That is almost a third of your deployment cycle totally eaten up by just waiting around. This alone proves we absolutely need a paradigm shift. We can't just keep throwing more human hours at this problem, because frankly, human reviewers just cannot scale with the sheer volume of code being generated today.
Moving to Section 2, beyond syntax and into semantic intelligence.
So how do we automate this without sacrificing quality? Well, there's a crucial difference between the old way and the new way. Traditional static application security testing, SAST, is deterministic and rule-based. It basically just asks, does this code follow the rules? It operates with a very local context, usually just looking at a single file. AI-assisted review, though, is probabilistic and learning-based. It asks a much deeper question. Does this code accomplish its architectural purpose effectively?
And this brilliantly illustrates the core of semantic intelligence. When AI evaluates code this way, it's not just looking at a flat text file. It actually views your codebase as a complex, interconnected graph of services. It understands data flow, dependencies, and business logic. Because of that, it recognizes your intent. It can actually tell the difference between a real violation and a deliberate defensive coding pattern, like a retry loop or a circuit breaker, which a rigid traditional tool would just blindly flag as an error.
But we do have to talk about the catch, often called the context problem. Standard large language models trained on public code have no idea what your internal conventions or specific audit requirements are. If you ask a generic LLM to review your code, it's going to hallucinate generic suggestions that completely miss the mark for your project. The fix for this is Retrieval Augmented Generation, or RAG. RAG dynamically queries your local repository to build a local context map. It literally feeds the AI historically approved pull requests from your specific team before it generates any feedback.
Now, what's really interesting about the math behind this context map is the limitation. You might naturally think, hey, let's just feed the AI all of our past pull requests. But research shows that actually causes what's known as context collapse, where the model gets completely overwhelmed by noise and its performance tanks. The sweet spot? Providing exactly 3 highly relevant historical examples. K equals 3. This gives the AI the perfect high-signal, low-noise context to stay incredibly precise.
Let's look at Section 3, the multi-agent workflow.
So, we have the semantic context down, but how does the actual review get processed? Well, the industry is shifting away from these massive do-it-all monolithic models, moving instead to multi-role frameworks. You can think of this as hiring a highly specialized digital engineering team. It's a rapid-fire collaboration. Step 1. The reviewer agent focuses entirely on hunting down defects and logic flaws. Step 2. The validator agent steps in to audit the reviewer's work, tossing out incorrect suggestions, nitpicks, or hallucinations. And finally, Step 3. The aggregator synthesizes all those validated findings into one coherent, actionable summary for the developer.
You might wonder, why use multiple agents at all? One phrase, false positives. Nothing, and I mean nothing, kills developer trust faster than alert fatigue. But by using this workflow, the validator agent achieves an impressive 75.6% F1 score for identifying false positives. It systematically strips out the noise that traditional static analysis tools constantly bombard you with, making absolutely sure that the feedback making it to the developer is actually worth their time.
On to Section 4,
catching deep design flaws.
So, by leveraging the semantic, context-aware, multi-agent intelligence, we are finally closing a massive security gap that legacy tools totally miss. Because here's the reality. AI-generated code might be syntactically perfect, but it often introduces really severe architectural weaknesses. We call these design flaws. For example, maybe the AI suggests using a shared secret key across microservices, which completely breaks zero-trust isolation. Or it defaults to giving new users admin privileges. It might suggest reversible AES encryption instead of proper hashing, or write administrative routes that just forget to include audit logging. Basic signature scanners are never going to catch these, because spotting them requires actual architectural reasoning.
Senior security engineer Srajan Gupta hit the nail on the head when he said, "Security is just engineering. Design flaws aren't a separate category of problem. These flaws slip through because traditional tools lack continuous, design-aware security rules tailored to your unique architecture. But Semantic AI understands how everything flows together, meaning it catches these deep structural flaws long before they ever get merged into production."
Which brings us to Section 5, Real-World Performance Metrics.
We've talked theory and architecture, but what happens when you actually plug this into a live pipeline? The hard data is incredible. The impact is totally immediate. AI instantly handles the routine stuff, syntax, style, basic logic checks in seconds. This slashes the manual review time for developers from hours down to literal minutes, which translates to a massive 70% reduction in manual review effort.
So the crucial takeaway here is this. Enterprises using these workflows are seeing a 3x acceleration in their pull request turnaround times. PRs that used to linger for 48 hours are dropping to 16 hours. We are clearing the single biggest bottleneck in the CI/CD pipeline. And, as a result, developers report feeling about 20% more innovative, simply because they aren't losing their creative momentum waiting around for feedback.
Finally, Section 6, the 2026 tool ecosystem.
Let's look at the top-tier players actually driving this massive acceleration in the market today. The ecosystem is specializing incredibly fast. Panto AI is bringing unified AppSec and context-aware reviews. Then you've got CodeRabbit, acting almost like a senior engineer by providing line-by-line PR summaries. Kudo has carved out a fantastic niche in deep path tracing and test generation. And when we talk about massive enterprise scale, Augment Code is stepping up to perform architectural dependency mapping across upwards of 400,000 files. These aren't toys. They are highly sophisticated components of a modern DevSecOps pipeline.
But as amazing as all this automation is, we cannot forget the human element. This quote from JetBrains really grounds the whole conversation. Automation accelerates you, but people give you perspective. The best pipelines have both. The AI brings the speed and the scale, instantly analyzing hundreds of thousands of lines of code without ever getting tired. But human engineers, we provide the critical architectural oversight, evaluating those complex trade-offs, and ensuring the code actually aligns with the company's long-term business goals.
Which leaves us with a really fascinating thought to chew on. We are rapidly moving toward a future of autonomous, self-healing software resilience. The baseline of code quality is being entirely automated. So, as AI takes over the routine checks, the syntax, and even the complex dependency mapping, what strategic role are you going to play in your next code review? How will your daily workflow transform when your primary job is no longer hunting for bugs, but validating high-level architectural intent?